In this lesson, we're going to look at some techniques that are often used when solving equations that involve decimals and fractions. Our first example involves decimals. All four terms are carried to the tenths place. So because we would prefer to work with integers, we're going to multiply both sides of this equation by 10. I'm going to show the work, but the reason we do this is multiplication by 10 can often be done mentally. We just move the decimal one place to the right, as shown. Finishing the equation is similar to what we've done in past lessons. In this case, we add a negative 2h and a 4 to both sides. Mark out the opposites. We get 46 equals 34h. Divide both sides by 34. And this one, we prefer to leave it as a fraction in lowest terms, an improper fraction, in fact, 23/17. The decimal for this is a long repeating decimal that's hard to identify the repeating part, also known as the repetend, so we would probably end up rounding this off, probably to the nearest tenth. But if we want an exact answer, we'll go with 23/17. Here's an equation that also involves decimals, but notice the two circled terms go to the hundredths place, while the other two terms just go to the tenths place. But we multiply both sides of the equation by 100. And of course, the shortcut is move the decimal 2 places to the right. Keep in mind that for the 3.2, a 0 must be added to move it 2 places to the right, and the same with the 2.8h. And now we're going to apply the definition of subtraction, add both 320 and negative 280h to both sides, find the pairs of opposites. We get negative 256h is equal to 462. We divide both sides by negative 256. And once again, we'll go with the improper fraction so that we can have an exact answer. Negative 231 over 128. Here's one that involves the distributive property, and I'm going to do it two different ways. The first way is to turn the point 4 into an integer by multiplying both sides by 10. And we get 4 times the quantity h take away 3.2 is equal to 140. Now we carry out the distributive property. Then we apply the definition of subtraction. And now we see that we still have one term left with a decimal in it. It's in the tenths place, so we multiply by 10 for a second time. And we get this. We add 128 to both sides. We find the opposites. We divide both sides by 40, and this one is not a repeating decimal. It's 38.2, so we'll go with it. But if you like the improper fraction, it's 191 over 5. Here's the other way to do this equation. Apply the distributive property first. Then look, and you have two terms with decimal places, but one of them goes to the hundredths place, so we multiply both sides by 100. Then we apply the definition of subtraction, and now the problem looks just like it did the first time. We finish it up, and we hope that the answer is the same, and it is either 38.2 or, if you like improper fractions, 191 over 5. Here's an equation with fractions. These are very common fractions. Most of us have memorized their decimal equivalents, so that's one way to go. Then we multiply both sides by 100, giving us 50m plus 75 is 25. Add negative 75 to both sides. Then divide what's left by 50, and we get that m is equal to negative 1. In this final example, we're looking at three very common fractions, much like the first one, with one exception. Two of the three fractions are repeaters. We know what they repeat to. It's not hard to find, but they're harder to work with as decimals, so we're going to leave them as fractions. But the way to perhaps make this a little easier to do is to find the lowest common denominator of those three denominators, the 6, the 3, and the 4. Well, the lowest common denominator is 12, because all three of those numbers go into 12. We multiply both sides then by 12. But it's best to show the work, because we really have three separate things getting multiplied by 12. Both terms in the left side get multiplied by 12, and the single term in the right side gets multiplied by 12. I show the work as I multiply the fractions. If you mastered multiplication of fractions, I hope this makes sense to you. If not, perhaps you should review multiplication of fractions. But when all this is simplified, we get a rather simple equation. We add -8 to both sides. We get 2m is equal to 1. We divide both sides by 2, and we can express that as either 1/2 or 0.5. To summarize, when solving equations with decimals, you may multiply both sides by a power of 10 so that all decimals become integers. When solving equations with fractions, you may change some fractions into decimals. You may also multiply both sides by the lowest common denominator of all the fractions in the equation.